All right, so our next example in the outline is called What Affects R. You're going to see like how we can change the data and what it does to the correlation. The first thing we're going to do is I want you to go ahead and type this into Staplet. So go and do testing a correlation and click it. And you want to put these in. The explanatory is going to be the X value in millimeters and then the Y value. So they're not worried about like the actual variables themselves. They're just showing you what happens when you change things in here. So we don't know what these actually mean, X and Y. We just know that they're two different variables that are quantitative. So go ahead and type those in and pause it if you need to and resume it when you are ready. All right, so once we got these typed in, I'm going to find R first. So I'm going to begin analysis. And I'm going to calculate correlation down here. Hit calculate correlation, and I get 0.918 as my correlation. And then I'm going to change the millimeters to centimeters and find R. So what that's going to do, let's bring that back up, is I'm going to edit my inputs, and I'm going to change these to centimeters. And there's 100 centimeters a meter. There was 1,000 millimeters. So it's going to basically divide all these by 10, like 1.2 centimeters in 12 millimeters, 1.5, 2.1, 3.2. So we're dividing all these by 10. And is it going to change the correlation at all? Let's take a look and see. Let's begin analysis. And the graph, the plot looks exactly the same. So it didn't change the plot at all. And if it didn't change the plot, do you think it's going to change the correlation? No, it isn't. It's 0.918 still. So actually changing the scale, the units, doesn't change the correlation. That correlation will still be there. And so the value of R does not depend on the unit of measurement at all. So that will not change your correlation. So the next thing they want you to do is switch Y and X. So they want us to switch X and Y. So I'm going to go ahead and do that. You can pause and go ahead and do that yourself as well. All right, so I went on ahead and switched them, and if you need to pause and do it, you can. But notice what I did here. I put all of the X values in for Y now. So Y is the millimeters one now. And I put all of the Y values in for X. I swapped them. And we're going to see if that changes anything. So we're going to begin analysis. See, it didn't change the graph at all. I swapped the X and Y axis and still got the same graph. And what do you think it's going to do to the correlation? It's not going to change it at all. 0.918 again. The correlations are the same even when you swap the variables and make one. So it doesn't depend on which one you label X and which one you label Y. You can have them in either slot and you'll get the same answer and you'll get the same scatter plot. So the last one we're going to look at is what if we cause an outlier? What effects are if we have an outlier right here? So they want you to change the 12 to 22 right here. So let's do that. So I'm going to go back to Staplet, and I'm going to change this 12 to 22. I'm going to begin analysis. And now I have this outlier out here that's going to mess things up. And let's see what our correlation is now. 0.627, it dropped it significantly. 0.627. So just that one data point being different from all the other ones and not following that same correlation dropped the correlation significantly. So that shows you that the value of R is non-resistant, which means an outlier can really mess it up. Kind of like, remember, a mean and standard deviation, the outlier could really mess it up. This works the same way. The coefficient, if you have a big outlier, it can mess up your correlation.